In this video, we're going to finish up the final steps of the PiTrac build. This is going to include things like installing the Shank Shield, the LED light that illuminates the teed ball, and optionally the little PiTrac emblem. Now, one of the last things you'll need to do is to figure out a Shank Shield for your unit to protect the cameras and LED and everything else. This is the shape of the Shank Shield that I've been using recently. Now, you don't have to make it this big, and to be fair, this is a little complicated because of these small cut-ins here, but the nice advantage about making it in this shape is that if you end up pointing your camera to the left or the right for higher speed shots, and I mean this top camera right here, what happens is the camera, unless the shield is this wide, the camera will actually end up picking up part of the edge of the Shank Shield in the camera's field of view, which you don't want. And so that's the reason for having this wider Shank Shield, which then requires, for better for worse, requires a smaller little tab here to mount into the unit. And you can see here there's two holes at the bottom which correspond to these two countersunk screw holes here and here. And then there's the two holes up here which correspond to these two risers. We can't currently 3D print the Shank Shield because that part is made out of acrylic or polycarbonate, and I just am not aware of an easy way that most people would have to print that part. This is the Shank Shield here, and it is the dimensions of the Shank Shield are part of the base box 3D model in FreeCAD in the GitHub repository under the 3D printed parts. If you want to get the exact dimensions so that you can build it yourself, those can be found once you open up the Basebox FreeCAD model. They can be found here under the Shank Shield body. You go to Shank Shield Sketch, double click on that, and you will get all of the dimensions for each of the elements that are going to be part of it. Now, if you want to laser print or something else to create your Shank Shield, you should probably be able to export these dimensions pretty easily. Otherwise, most people are just going to create this manually. Now, there's a couple pretty important safety notes with regard to making these Shank Shields. The most important one is that if you're using plexiglass like this or polycarbonate, the edges, if they're not rounded down, can be extremely sharp and like sharp enough to cut pretty deep. So you really need to be careful when working with this, especially if you're going to be trying to score and then break the plexiglass or polycarbonate. There's sort of two ways of doing this that I've tried. One is I've taken a slow-moving bandsaw and just cut by hand all of these lines, and then used just a regular drill bit going fairly slow to cut out or to drill the holes. The problem with that is even with the slow-moving bandsaw, it tends to melt the plastic, and so you end up with a bunch of rough, you can kind of see maybe some of the remains over here, this very rough stuff which you then have to pry off or cut off or sand off, and it's kind of a pain. You can, especially if you're making a simpler Shank Shield, the one that just would come like this without these two wings, one that would just basically be the size of a rectangle. Because it's a rectangle and it doesn't have these insets, it is possible to take a very sharp knife and score along a ruler and then break the plexiglass along that score line. That is pretty dangerous, so if you don't know what you're doing, and even if you do, I would wear gloves, and pretty high gloves, just to make sure you don't snap something and then snap it into an artery or something like that. But the nice thing about scoring and breaking is you do end up with a pretty clean line, and it in some cases is actually a lot faster than cutting it with a bandsaw. However, because I cut this one with these shapes here, kind of had to use a bandsaw for that. Other things to consider are that the plexiglass is pretty easy to scratch. A small scratch shouldn't really affect the optics of PiTrac that much, but you really have to do your best to try to keep the scratches out of the way of where the field of vision is going to be. Let's see. Finally, I think I used M4 self-tapping screws both for the top here and the bottom screws that attach the Shank Shield. You'll note that the two screw holes here at the bottom are in the same area where you're eventually going to put your LED lights. And so you need to be careful to make sure you run your LED lights in a way that doesn't get into or doesn't interfere with those holes, and doesn't interfere with the little hole that's being used for the PiTrac calibration rig here. The other thing is you don't want to screw these screws in very tightly. It's easy to crack the glass if you really crank down on it. You also want to make sure that you've drilled holes that are significantly bigger than the screws you're going to use. If you're using self-tapping screws, you do not want to have them cutting into the polycarbonate. It might make sense that that would add some perhaps strength to the screwed in mount, but it actually has a pretty good chance of cracking the polycarbonate or the plexiglass if you drill too small a hole. You don't want the threads of the screw biting into the plexiglass. You just want the screw to come through and have the threads only bite into the portion of PiTrac that it's going to be mounting to, here or down here. Next, we'll build the light that illuminates the teed up ball. This is an LED strip that's just cut into multiple pieces so that we can fit as much illumination as we can into a small area. The reason for this light is that the top camera is taking very fast pictures of the teed up ball to try to make sure that it doesn't miss any movement. So we're taking about 600 or so, maybe even a little bit more, closer to 700 pictures a second, which means that the shutter speed, the length of time that the shutter is open and the camera is actually looking at the ball, is really short, and so it doesn't have a lot of time to get a lot of light. And so the purpose of this really bright LED strip is to try to push enough photons out and hitting the golf ball that there'll be enough light even for the short shutter times. As far as which LED strip light to purchase, really most of them will generally work. There's 4 requirements for the LED strip light. One, it's got to be at least 5 feet or so long, so you have enough length to cut it up into at least 4 little strips to mount on the front of the PiTrac. Second, it's got to have a 5-volt USB input, because that's the power supply we're using. Third, it needs to be capable of being cut into strips, and you can see from the picture here, usually there's little copper ovals, and so long as you cut in the middle of those ovals, you don't interfere with the operation of the LED. And if you want to connect 2 pieces of strips, you just have to connect those 2 halves of those ovals together, which we'll go through in a minute. And then finally, and fourth, the LED light can't put out any significant amount of infrared light. The reason for that is if the LED puts out infrared light, and of course the LED is on all the time, then that would mess up the infrared system that's used to generate the strobed images of the ball in flight. We'll start by taking the LED strip and cutting it into pieces that will fit across the bottom of the base box, as shown in the previous image. We want to make the strips just a little bit smaller so that the connecting wires aren't sticking out beyond the edge. They might catch something, but you want them as long as possible, generally just so we have as much light as possible. Now, when you cut these, you have to remember to cut them only across the little copper ovals. Do not use a pair of scissors to cut the LED strips. Use a clipper, such as the blue-handled one that's shown here. If you try to use scissors, it tends to shear and mess up the LED strip. Now, once you've cut your strips and you've sized them to the base box of the PiTrac, the next thing to do is to create a little rig that you can solder on. Now, we're going to be soldering and putting some pressure directly on these little copper pads, and so anything underneath those pads is going to get pretty hot. For that reason, I find just using a thin strip of board or 2x4 or something like that that isn't going to melt or catch fire usually works pretty well. And the way I've done it is you take your strips and you lay them out and then tape them down. Don't tape them too close to where you're going to be soldering because you don't want the tape to melt, but something like the rig that's shown here works pretty well. Now, if you are already a pro at soldering, you can probably skip a lot of this and just put it together however you see fit. But if you use a pointer or two, here's one way of soldering together these strips. First, get some decent rosin flux and brush a little flux on any of the metal components that you expect to solder together. That's going to help clean it and help the solder adhere. That's what this picture shows here. We're putting a little bit of flux onto the two copper pads that we expect to solder some wires to. Next, cut some very short little wires, preferably using really thin, maybe 24 gauge wires. These are the wires that are going to connect each of the segments of the LED strips together. When you do so, you want to make sure you don't have too long of a stripped lead. Strip it back to, I'd say, maybe 1/8 of an inch to 1/4 of an inch. Now put a fairly hot soldering iron onto the little bit of copper that is at the end of your LED segment. Heat up the rosin for a moment and then put a little drop of solder right where your solder tip is. Lift up the solder, then pull away your tip, and you should have a little blob of solder all ready to go, adhered to the copper on the LED and ready for soldering the wire. Next, dip the stripped end of the wire into the rosin. You can see here I've only stripped one end so far. You'll have to obviously cut and strip the other end and dip that one in rosin as well. I use a tweezer to hold and position the wires. What you do is you position the wire so that its stripped end is right next to the little solder blob that you laid down earlier. Then you put down your soldering iron, heat up the blob, move the wire into the still molten blob, then move your soldering iron away and hold the wire in the blob of molten solder for about 2 seconds until the little blob becomes solid. Please note that if you're doing this with metal tweezers like I'm using here, at some point the tweezers may start getting sort of hot, so be careful about that. Continue this process until you have all of your segments wired up And when you're doing so, be careful to make sure that you are wiring the negative parts together and the positive parts together with the wires, and you're not taking a wire and crossing from positive to negative, which could destroy the LED light. It's easier if you're using red and black for positive and negative respectively. I'm using blue and white here, probably because that was the only thing I happen to have lying around in the right gauge. Whatever works, just try to have a consistent color scheme and make sure you don't cross the polarities as you start connecting these various segments. When you're finished, you should have probably 4 strips that are all connected together, with the last end of the strip not having any solder connections on it, and then 3 parts that are connected by 2 wires, and finally 1 part which connects all the way back to the USB plug that powers the strip. At this point, before doing anything else, you should plug in the strip, make sure that all 4 segments light up, and you should be ready for the next step. You should note here that the strips are arranged on the front of the PiTrac to avoid the 2 mounting holes for the Shank Shield, and although it's a little hard to tell here, we also need to leave a little room to get into the hole where the calibration rig will temporarily attach to PiTrac when you're doing auto calibration. Now we've already soldered our LED lighting strip here together. It's a little fragile, so you have to be careful with it, of course, but we've basically got this, so we've got the strips that are the right length, and there's 1, 2, 3, 4 strips that are going to go along here. This should provide adequate light for the unit to watch the teed ball. The one difficulty with this is that the current print doesn't have a hole large enough in the base here for most standard USB devices to go through. So instead of just, as you would hope, putting this through the hole and bringing it out and up and then linking it into the USB power outlet here on the PiTrac connector board, instead of doing that, you have to instead generally pull the power supply out, which of course is easier if you have some quick connects, and then feed the LED strip through the unit and out the front here, and of course all the while hopefully not breaking your delicate little solder connections here. Hopefully in a future version of PiTrac, this slot here will be a little larger. Once we've gotten the LED to the point where most of the cord here is inside the unit and just this part is outside, of course, we have to deal with then sticking the LED lights along here and doing so in such a way that you don't interfere with the holes for the Shank Shield or for the calibration rig. And most of the LED strips that I've seen have adhesive on their back. This one is actually this one still has its blue adhesive cover that you can peel off and then stick down. I found that the adhesive isn't all that great. In fact, you can see this one here is pretty messy, and that's because what I've been doing lately is actually forgetting about using the adhesive of the LED strip and instead using some two-sided tape. 3M VHB tape is a pretty aggressive two-sided tape. It's maybe almost too much for this application because it's really hard to get off later, but that is one option, or something like it. And you can just cut out some two-sided tape, stick the one side down here, and then just, without pulling off the adhesive cover on the LED strip, just stick the LED strip down to it. The key is you want to make sure that the LED strip is roughly between these 2 slots, because doing so will hopefully ensure that when you then add the Shank Shield, which fits basically here like this over to here, you want to make sure that the Shank Shield is going to cover those lights so that the golfer isn't going to be seeing the lights from the sides when they're golfing. The whole point of the light shield that goes right here is to prevent that. So you want to make sure your LED lights don't go too far over to the edge where the shield isn't going to be effective. Now it's obviously not required, but if you want to add a little PiTrac logo like this to your system, I've been putting them right here, or if you just want a cool PiTrac logo, they're pretty easy to make. The letters are printed out separately. I've been printing these out with orange for everything except for this little part of the pi symbol there, and then printing out the background in gray just because of the filament colors I had. In order to assemble one of these, after you print out the letters, which are a little hard to get up from the print bed, once you finish printing out the letters, which are a little hard to get up from the print bed and usually take a fingernail or something to kind of pry off or move sideways first. Once you've done that, you can see that the PiTrac board has indentations, pretty shallow little indentations for each of the letters. And the idea is to glue these in here and hammer them in a little bit so that they stay. The letters are actually just slightly oversized for the gray background. So what I've been doing is just using a toothpick and some super glue, and then just dabbing a little bit of the super glue into the indentation where the letter goes. And then finally, when you put the letter in, like say there, it usually takes a fair amount of pressure to get it really set. So what I've been doing is using a wooden block and a non-metal hammer, something like this, to get the pieces hammered in to their final location. And between the pressure of hammering them in and the super glue, they seem to stay pretty well. I've been gluing the actual logo to the unit just using this same cyanacrylate based glue.